The best way to teach a kid something is to make it relatable to them. That's where our new educational product comes in. This is the electronic body. It's a highly accurate line-following robot, but it's not just that. We've also designed it so that every component maps to something we can all relate to, the human body.
The electronic body features a simple user experience. Simply place the vehicle on the line, turn it on, and use the provided emergency stop to allow the vehicle to go along its merry way. And enjoy, as it successfully negotiates challenging turns. The electronic body features stickers that provide the anatomical equivalents of electrical components, providing a meaningful educational experience for students aged 8 through 10. The AV subsystem facilitates the determination of line alignment, consisting of a piezo buzzer and 3 LEDs. Take a listen.
The electronic body has an audio and visual system that is highly sensitive to sensor feedback. The visuals are simple yet effective. There are 2 blue flashing LEDs like turn signals on a real car, and 1 center green LED indicating whether the car is aligned or not. For audio, the electronic body plays a C note when it's on the line and a D note when it's unaligned. The sound is produced by an amplifier and a small speaker. With this feedback, students can easily understand how the car senses the line and changes its movement.
Hello, my name is Daniel. I'm going to share with you the software utilized by the electronic body. The software framework uses a modular file structure in Arduino IDE where each individual subsystem is compartmentalized. This helps with debugging as well as testing. Each subsystem then interfaces with one central control loop. The control loop uses a PID controller, which is easily reconfigured by the end user, and the controller weights can be adjusted accordingly to the desired end result. The way it works is like this. A weighted sum from the sensing array with the preference on the centermost sensor calculates the error. This is fed into our controller, which then calculates the gain of our output. So whether this is to turn left or turn right to remain straight, this sets the output for not only the AV system, but as well as motion.
This is the power rail, the heart of electronic body, where we supply 3 power loops, 3.3 volts, 5 volts, and 11 volts. The motion subsystem takes in signal from control module and adjusts the speed accordingly. The signal used here is PWM as shown on the screen. It varies with the motor output. Aside from offering great line tracking performance, the electronic body is also designed with safety in mind. We have remote safety start-stop feature for educator to control the robot at will.
The sensing array uses 5 pairs of infrared LEDs and photodiodes to detect the vehicle's position relative to the line. Comparing the quantity of reflected infrared radiation received by the sensors on the left and the right, the control algorithm determines the vehicle's orientation. The photodiode interface circuitry provides significant contrast between low and high reflectivity situations. This ensures consistent performance and minimizes unwanted jittery movement due to ambiguous readings. An attractive acrylic subframe securely mounts the main PCB and daughter board that hold the bulk of the vehicle's electronic components. The electronic body can be assembled with simple hand tools, thanks to a modular architecture featuring standoffs and terminal blocks. Mechanical reliability was achieved through testing on a prototype chassis, motivating decisions like using 3D printed motor mounts over L brackets for improved durability.
Getting a kid into electronics doesn't have to be confusing. By using simple anatomy concepts to explain a complex system, we're providing a platform that makes engineering fun, engaging, and most importantly, relatable to everyone. So what are you waiting for? Draw your own line on the floor and watch the electronic body come to life.